Class example 3.55. A gallbladder scan involved the injection of 0.65 cc's of technetium-99m, which is a radioactive isotope. After 10 hours, there was 0.2 cc's measured in the body. Determine the half-life of technetium-99m. So we're going to start with our growth decay formula on your formula sheet. Now, we know that our end amount is 0.2 cc's, and that our initial amount was 0.65 cc's. Based on the question, we know we're interested in the half-life of technetium, so our B value is going to be 1/2. And now we have the exponent to solve for. Now the question is, are we given P in this question, or do we want P? Well, we actually want P because it says determine what the half-life is. So remember, our P value is the amount of time that goes by in order for half of our substance to remain. In other words, the half-life. Our P value is the half-life if our multiplier is 1/2. And then the 10 hours, well, that's how much time actually goes by. So that's our T value. So that's 10. And now we want to solve for P. So first step is to isolate the power term. So divide both sides by 0.65. So next, convert to log form. So log 0.5. Well, where did the 0.5 come from? Well, that's just the base here, right? That's base 1/2 when it was in exponential form. So log 0.5 of 0.2 over 0.65 is equal to the exponent, because logs solve for exponents. And yeah, the best practice here is to leave this decimal until the very end, until the last step, and then we'll put it all in your calculator. That just gives us typically a more accurate answer, because if you divided 0.2 and 0.65, you'd have to round that decimal. So just leave it in this form up until the very end. Okay, now multiply both sides by P to get P out of the denominator in this case. And then divide both sides by log 0.5 of 0.2 over 0.65. And putting it into your calculator, we get 5.88 approximately, or 5.9 hours. Now, if you have an old school calculator, you'll have to write that as 10 divided by, and then it's log 0.2 over 0.65 divided by log 0.5. That was the base in this case, right? And good practice here, make sure that everything in the denominator was also in brackets. So notice those. All right, B, determine the rate of loss per hour of the substance. So first step, find the substance amount at 1 hour. So here was our equation from before. And this time, we don't know what the substance amount is. We're going to solve for that. We were given it originally, but this is a new question. We're going to solve for Y when T is 1 hour. So in this case, we have 0.578. Now, if we know that this is what's left, and we also know our original amount, now we just have to find the percentage. We just have to figure out what that percentage is. So in this case, this was just putting this into our calculator to get 0.578 in your calculator. And then we're taking that number and we're just going to divide that by 0.65. That's just the amount we have divided by the total, right? We're just finding the percentage there. And then we just careful on this though, because that's what would be left. But it says determine the rate of loss per hour, not what's left, right? What we just found there was what was left. We want to find the percent that we're losing every time. So in order to do that, we're going to take 1, like 100%, minus our last answer. So our rate of loss would be this one. So in the end, that's written as a decimal, so times 100, 11.1 percent per hour. Now, an alternative method would be to solve for our B value in this equation. Now, you might be saying, yeah, but I thought our B value was a half. Well, that was like another way of looking at it, but in that case, it was a half after a certain amount of time went by, right? And we solve for that. We solve for that P value in that one. So we're actually going to make a different equation, but our B value is going to be the multiplier for a single unit of time, so 1 hour. So if we solve for B here, then we would divide both sides by 0.65. And then take the 10th root of both sides to remove the exponent. You can also think about that as 1 over 10 instead of the 10th root, just writing that radical as a fractional exponent. And then our B value would be 0.89. But we don't really want 0.89 because that's how much would be left. The question was saying determine the rate of loss per hour. So again, we're going to go 1 minus our B value to get 11%. You can see here that we would just multiply that by 100 to get 11%.